Okay, hi everyone. A very good evening. I hope I'm audible perfectly. Right, can you please acknowledge about it? Good evening. A very good evening to each one of you. Can you please acknowledge that, okay, if everything is going good? Say yes or no, please. Write it over there. Okay, that's good to know about it. So, I guess let's wait for another 1 to 2 minutes. A very good evening. A very good evening to all. Thank you, Makesh. Thank you all. So I'm just waiting for another 1 minute, okay? Because today we have certainly very important thing to go ahead. Correct. So I just wanted, okay, to everyone to just join in a quick minutes, so that I can just share and just begin with the today's agenda. Perfect. So as per the today agenda, what we have, and first of all, let me just clear from your end. Is it okay? Everything good? Okay, from the day 1, day 2, day 3. Okay, so we all had done with the certain approaches of the day 1, day 2, day 3. So there was, and the resources are already uploaded into the drive file. The link has been shared, okay, with you all. So I hope you got it, the drive file with the ppts, okay, and all, including the detailed ppts are being there. And please share your link, it's already there into the description, okay. So you can just check the description, or you can say of this particular bootcamp. My email id is already being there. Okay, I guess it's of someone else. I'll put it mine also. You can search it, okay, the Techie Anshika Gupta. You will easily find it out on the LinkedIn, or either I'll be sharing with you. Okay, so what as an of the day 4 we have, okay, or what we just need to start on a particular day 4 and all. It's quite simple. Very good. Okay, as per yesterday we did I would say arrays and the pointers, array strings and the pointers were there. As one of the day 4 in the CPP, we are just gonna go with the key data structures, which is gonna be combining with stacks, queues, linked list in CPP, right? Now the point depends upon how it looks like about the introduction towards this. Hello everyone, let's just be quick with it. Alright, okay, please join and let's start with it. So an introduction towards the data structures, the 3 about it, and why it's being so much used, okay. Basically the more obtainable part what we have, okay, over here is in the world of the computer science and the software development, okay, the data structure is being playing the backbone of the efficient programming. Among the most essential data structures are the stacks, queues, linked lists and all. Each of them is being playing a very critical role in solving the real world problems and building the optimized applications. Now when we say that, okay, we wanted to just start with optimize data structures algorithm, what does it mean? It means basically is what is being there, and how it has been attained with more of the conditions, correct? Doesn't matter like okay what and how we wanted to just write it, but it all also like okay gives you a one key point out of it, that's what lead okay towards it, okay, about the data structures algorithm. These data structures algorithm are not only just a foundation, but it is also a more solving or understanding the complex problems to the easier manner, the optimized way. So kindly please give I would say an importance to this topic, and as well as the yesterday's topics also, because both of them is covering like at least 40 to 50% of the data structures algorithm, correct? These data structure algorithms okay into the CPP is a very powerful and the program performance object oriented, though we know that these structures can lead towards what we required and how we required it. What are these data structures widely used, and why okay we give so much importance? It is my personal favorite, to be honest, if I'll say, just because of its own simplicity, okay, uh, the efficiency, the ability to model the real life problems such as the undo operations, correct, uh, the job scheduling, memory management, data organizations, and everything. So I would definitely say that if you are learning this and if you have focused and went towards day 2 and day 3, your 50% of the data success algorithm is done. I would say 50 to 55% is done, already done. Okay, uh, what does this mean? I'll give you a very brief about it, which is being there, a short of it, a stack, correct? You need to remember the word stack with the help of a method that is known as LIFO, LIFO. That's last in, first out. Okay. With the queues, you need to remember it with the basically FIFO. Now LIFO and FIFO both are gonna use as one of the proper algorithms. Okay, it's required it. Just like okay you just need to call the function, you just need to call the expressions, the evaluations, the backtracking algorithms, and everything. Now what is a backtracking? Okay, in a layman language I'll make you understand about it. Let's say you had went towards a route, okay, route you went, okay, and you wanted that you don't visit okay that route again from that particular uh, distance, okay, you wanted that you should not visit okay that particular route okay from that distance. If you're going from A to B, okay, you wanted to go you wanted to come from to destination A, I wanted you not to come from B to A. Okay, what I just wanted is, if you already had traveled that route, okay, now you wanted to just go with A to B, B to C, and C to A. Okay, so this is how you, once you visit any kind of a route, okay, now it's your point that you don't wanted to just revisit it from the same kind of the path, okay. And if you don't wanted it, make sure this is a backtrack, okay, you all visited with all of the things again, now you don't need to go with it. Q is also like that, which is gonna be having the deep search about what you are just returning for, okay, the deep search for what you are just trying to return for and how you're just gonna return for, okay. And if the values okay are gonna be backtracked, okay, or if the values are just gonna be just normal, okay, and how you're just gonna be returning it back, you are already going to be returning that particular actions. Whereas linked list, it's long positions, okay, of chain like structures, elements we used to write it, and in this the positions you can add upon, delete it, and all, okay, that's a longer kind of an inspections, okay, we will be having it. Now how do we make it in an application? So similarly, just like you are being okay into the proper set of the working internally. So once you just walk internally, make sure that each of the walk which you have is not gonna be the appropriate. Okay, it should not be appropriate what you are just trying to write it. Correct. The programs is quite good of them, so be a proper eye onto it. So these PPTs again you will get it okay into your file, so never mind about it. Okay, so only keep an eye that you focus onto the programs and you understand what we are just trying to do it. That's it. Okay, and if you are just understanding that, you will easily just properly like okay have the entire kind of an agenda, right? Entire kind of an agenda would be fixed about it. Why does these data structures again all matter? In CPP, Python, Java, any language, okay, C, overall these structures okay does matter, okay, does matter, okay, about what you need to write it and how do you need to make it a career achievement. Now most appropriate way is like what is the technical interviews. First of all, when you give an interview, make sure wherever you're just giving an interview, always present that language only which you know, okay, which you know. And if you don't know that particular language, okay, that many I've saw many of the people like okay like this, they put the languages okay that I need Python, I know Python also, I know this language also, I know that language also, and so things, correct. But when the interviewer okay when the interviewer just asks about that particular questions, correct, whenever the interviewer asks about that particular questions and everything, what happens is then you don't know, okay, you to write like okay just to fill the spaces that I know Python also, I know this also, I know that also. But when the interviewer asks you about from that particular language, then you just get blank, correct. Okay, then you just get blank, correct. So why I'm saying about is write only that languages which you know. Do not overshow your languages like just putting 3 or 4 and all, okay, and all. And this will just make you feel like okay that why should I have wrote it, okay, why did I have wrote it, okay. And it will becomes okay very problematic for you itself, okay, it will be durably I'm saying it will make a problematic for you, right. Now in this, what is a stack in a very detailed way, I'm just gonna make you understand about what is a stack. Stack is known for a method that's known as LIFO, okay. Stack is known for a method that is known as what? LIFO. LIFO is a concept, or you can say LIFO is a method the last element inserts into the stack, okay, and the first one removes. That say like okay this is a basically let's say the stack of the plates. From here I'm gonna add upon from the lower, from the upper it is gonna move out, correct. Each and every of that it's just gonna be inserted into a stack with the first one to remove, and this behavior resembles like okay how the stack of the plates when you remove is gonna give you the advantage of it, right. So there are 5 operations, okay, whereas we calculate as of 4 operation, the 5th one is size, correct. It's a very powerful look the stack, whenever you don't get anything to apply, okay, you always say like okay you are applying the stacks, correct. With the stacks there is just a point of it, the 4 operations. First of all, the push, pop, top is empty, all of these four operations we will be having the solving the questions also, problems also. Okay, the push means when you insert an element. What does a pop means? Pop means when you remove the top elements, right? Okay. And what is a I would say top, that when you peak the top element, that means this is like, okay, the set of the plates, okay, in a restaurant, resorts, cafeterias, okay. And from here, from the top of the view, I'll be seeing what is the top view of my place, correct? It is like overall I'll be just seeing, okay, that the plates I'm just gonna check, right? The top is among that, right? The top is among that. And that means with the top we used to say peak also, right? Okay. And there is another one we have as empty, checking if the stack is being empty. Okay, checking if the stack is like quite natural, okay, to remember, and natural to just write it, correct? Now, what does it matter the most out of it? Okay, why do we need to write it, right? Okay, the most appropriate out of the context what you have, okay, and how do you take for the later of the aspects with the stacks and the queues is empty when every single thing is in the stack contains the empty out of it, right? Or you can say the empty of the conditions are being there, right? So now let me just take you towards one image. So this is an image, right? Okay, if you see this image, first of all, just have a look onto just a stack, okay. Adding an element, okay, that's a push. Removing an element, that's a pop. Top view of the individual cell, okay, and then it comes as is empty, the whole of that, okay. This is a stack, okay, which it remembers about the capacity, you just need to write it, okay, and how the capacity you just need to write it, and how what you need to implement it also. Why and where we use the stacks, basically if you have recursion means many recursive problems are being there, the function which call itself, the backtracking where the stacks helps us to undo the operations like navigating a web browser histories and all, okay. Expression evaluation, there is a one concept, that's an notation, postfix, prefix, infix notation, you can read about it, okay. It's a quite lengthier kind of I would say the topic is being there, but you can read about it, the what is a suffix notations and everything, okay. After all, we have the certain kind of another points also to be remembered, okay, over here. When each of them has been trained with a stack, okay, there is something that is known as the containers, SD stacks, okay. Whereas the size of array is also going to be like, okay, fixed, just like, okay, we have arrays, correct. And after that, when we say these operation, it is gonna be just resembling, okay, that what you just need to write it, correct. Now let me just open the VS Code and let's do one question out of it. How do we write it, okay, the stack, this is the way, but first of all let's start with it. Can you please open it? First of all we will do the stack, then we will do the queue. Check it in the CPP program, let's delete it out, okay. What we wanted, okay, over here is include IO stream, okay, make sure you have it properly, okay. hash include and all. Okay, now I'll also include the stack because I'm using stack, so I'll be importing the stack also, so that it helps me out when I just gonna render it. So int main, let's say the entry point of it, the stack int, okay, the value I'm just gonna say an int, and then we can just make it a small variable also out of what you just need to require. Sorry, int main, my bad. Right, stack int, okay, you can just write it, and you can just simply write it s. Okay, now let's push the element, so I'm just gonna write it s dot push 10, s dot push 20, s dot push, these are the three elements. Okay, I've just pushed it. Okay, so that's basically 30. Okay, three elements, I've just gonna be pushing that. Okay, after that, top elements. Okay, so we just need to see what is the top element of it, so we are gonna write it cout, which is an output, so we are gonna write it less than kind of it. Okay, all of them, top, push and all. Okay, we're just gonna say that. Okay, so we're gonna see the top elements now. Okay, s dot top operation endl. Okay, the operation stops. Okay, over here. So when we see this operation to have it, okay, it will just ask you which operation and how you wanted to just go with it. Right, which operation and how it is basically rendering the top element. Okay, now if you see that this is gonna give you an error, the stack is undefined. Correct. The only reason why it has, okay, the time name is not allowed, okay, and all, line number 4. So this is nothing but only endl is undefined. Okay, so why does it endl it should not come with an endl. Let me just put my documentation itself. Okay, or either I guess some indentation errors we can take it. Okay, doesn't matter. Now this one, upper one is like, okay, like what for the top elements. Okay, or might be like, okay, I'll just write it. Okay, the cout for the stack elements, top after pop. Okay, so you can give the addition out of it. Okay, so if you wanted to keep the pop element, so you need to give like, okay, s dot pop. Okay, after that just close that. Okay, give it a condition of cout once again less than the top after pop. Okay, here you just can define less than s dot top. Okay, the values to be given, and again the endl. Okay, so this how the operations, okay, whichever you wanted to go with that, okay, it will come. Secondly, we will be having the size to be calculated. Again, we can calculate the size, okay, like this, s dot size, which is just gonna tell you how much amount of elements we have. Correct, that's in stack size. And if we wanted to just check if the stack is empty or not, okay, you can put in a code about it, s dot empty. So all of them gives you a conditions, okay, that okay, it's in empty or not, or will the value comes. Correct. So now in this, okay, can you let me know what would be the kind of the output would be there? Anyone? What would be the output? Tell me please, what would be the output of it? Anuradha Sharma, please don't ask about the attendance. It happens at the end of the lecture only, or the session you can say. Okay, it happens at the end of it. Top element is 40. I guess who will write it like this using the namespace STD. Okay, I haven't brought that. Who will write it? Top element is 50. Okay, so let's see the output. Terminal, let's compile our code firstly, and then let's see what is the output of our. So you can see there's the output. Okay, top element is 30. Obviously 30 would be there. How can God be like, okay, the 40 would be coming? You're not 40, right? How about the 40 would come? Tell me that. So 30 is the top element because obviously last in, first out. Okay. Then 20 is the top after pop. Okay. If 30 is being removed, now 20 would be the left out elements. Correct. Then it's been asking me like what is the stack size. So stack size will be like okay, what after pop. Correct. Okay, the stack size okay will be remaining by the 2. Or you can say if you wanted to calculate with the stack size, you can give it as an of index value also. So you can give it 0, 1 and 2. If the stack is empty, okay, or not, obviously not, because after 20 it was not even the pop. Okay, so it is not gonna be happening for what we require it, right? So this was a stack. Okay, this was a stack code. Okay, which you should remember it for later aspects also. Now when we talk about the stacks, okay, and all, okay, into the stacks, what all the condition it matters, okay, over here is the queue. Correct. So whatever the slides are being there, we've skipped and all, okay, you can read it yourself. Okay, this is just an external information needs to be provided. Okay, which you can at least begin with what you need to start at, right? Depends upon these actual kind of an implementation, or like, okay, you can say the actual values, okay, out of it. Clear? So now let's begin with what is the queue. Okay, when we talk about the word that is known as a queue is always going to be a very simple. Queue means the FIFO concept has been followed up. Okay, that is known as FIFO, first in first out. The functionality provides the I would say queue data structures. The queue follows the FIFO principle, where the element itself has to add the first, okay, and then remove the first out of it, right? But the main thing over here, the operations, like, okay, what does the operation mean? Okay, over here, when we talk about the operations into this, Priti, now the attendance is not gonna allot. Okay, once we are ready with the class ending, so you will get the attendances. Okay, right now the attendance is not gonna be provided. At the end of the class, you will receive the link, and there you have the attendances. And what is a queue? It's a linear structure that works with the FIFO principle and abstract data, unlike a stack knows, like, okay, which removes the most recently out of it, right? In this, the most important thing what we have is the core operations. NQ is adding the element to the rearer, that means back, correct? DQ means removing the element from the front of the queue. Okay, front means viewing the front element without even removing it but accessing that particular link. Correct. What it's there, empty space balad malapati. So front means like, okay, you are just viewing, okay, all the front elements without removing it. And the rear is the back end part. Okay, all the back end parts and everything you would be just trying to view only. Okay, you don't need to remove it. Okay, anyhow, if you're removing it, that doesn't make sense. Like, okay, how would it be there, and what all would be it's gonna be there and all. Okay, so that's gonna as an of now. After that, it is empty. That will be just checking, okay, if the queue contains the elements or not. Okay, a real world scenario is being there, just like a real world scenario. You a customer which is being there in the ATM. Okay, it's in chance like, okay, the very first person who is into the line will be able to just use the ATM machine, right? Okay, the person who is behind, that is like, okay, gonna be using the again the different when the time comes, right? Ma'am, I've missed the previous lecture. Okay, date to attend, so you can only have options to see the recording. Okay, it's already being streaming on the Smarted YouTube channel, so you can just go with that. Stack is empty until unless you have the element stored into it. So those who have missed the yesterday or day 1, day 2, day 3, I would say the boot camps, okay, they only have an option to just see the recorded one. Okay, it's already streaming onto the YouTube. You can go with the playlist of that. Okay, and it's already streaming right now. Okay, so you can just get with that, and you can ask me the doubts if you have anything by tomorrow, right? So now, if we have been using the public transportations, okay, the boarding transportation, the first one to come is the first one to enter. Okay, the last one to come is the last one to enter. Correct. Or you can say you're going to any shopping mart, okay, and all, to buy any groceries, okay, or your personal items, okay, clothes and all. So the a proper kind of a line would be there. Correct. uh, it is not a point like, okay, and it will not look good also. If you will go in the front and just go over the billing when you arrive late also, right? So this is only one condition which is being there, and it will tell you like, okay, that this has not been even allowed to arrive. Correct. The more appropriately the basics of it, okay, is the queue. The first one to come is the first one to serve. Correct. First in and the first out. Similarly, in this, the applications are there with the networking web servers. Okay, you have the BFS algorithm, okay, and all. Correct. The concurrent kind of a programming is being there. So these arrays based queues, the linked list, which we are just gonna do it now upcoming way. Now these point of the queue is kind of three things. Okay, there is a circular queue, there is a simple queue, okay, and then there is a linear queue. But the point that's remembered, okay, or the point which is being there, and how does it matters, remember that, okay, the conditions are not gonna be the same all the time. Okay, there is something like, okay, which is gonna be getting it changed with what you wanted to write it, right? So now there is a time complexity. Do you know what is a time and space complexity? Do you know what is a time and space complexity? Anyone? Anyone over here Who knows what is the time and space complexity? Okay, no. One go to program. I'll be going with the program also, but I'm asking you, do you know what is the time and space complexity? That's my main question. Okay. What is the time and the space complexity basically is? Time to take, okay, or you can say, first of all, space is just a memory. Memory it is taking, okay, or memory it has, okay, to go with the two fundamental concepts are being there. Time is how much time it has been taken to measure the execution time of the algorithm, which grows with the input size, correct? One question I have, okay, how much time I'm taking to solve it, okay, and how much space or how much memory space I required for that algorithm, okay, to run, okay. So this is a time and space complexity, right? And it gets measured. There is a logarithmic, I would say, the way which is going to be just considerate of for what you are just trying to write it, okay. But how do we write, okay, these are queues, okay. So if you see this one, q, nq, nq, rare, front, dq, first in first out, okay. Nq, you already know the meaning of the nq basically as what? Nq is adding, dq removing, front view, okay, of it, okay, rear also it's in view, right? Now, very good, Soumya. Okay, that's really good of you. Now, how do we write, okay? What exactly we need to write, okay? And how do we just make sure, like, okay, our program is running all perfect with all the approaches and all? Right. One of them is like what we just need to write it as is the program which is getting it executed. So let's copy it, comment this one, paste it down. Instead of a stack, we will be writing it queue. Okay, so queue would be there. Okay, so after that, instead of like, okay, the namespace and all, we are just writing it. Instead of stack, we will be writing it queue. So I'm telling you how do you go with, okay, these things, queue and queue, okay, over here. So instead of writing a push, okay, with it, so obviously it's in queue now, okay, we will be just writing it and replacing it with queue. 10, 20 and 30, the elements are quite same. Surely I'll look forward, I'll just discuss among that, okay, if we can take it about the full stack also, correct. We can think about it, okay, it doesn't matter. But first of all, just focus on to this, right? That's because more important. Now, after that, once you do it, obviously it's not the operation from the stack, it's an operation from the basically the queue, right? So we can just write it front and rear, you can say the back view of the elements, right? It's not like this, it's in queue front, okay, and then endl and queue back that endl, right? And then we will be just trying to put one operation, that's queue pop, q dot pop. But instead of like this, let's just not write it initially, we can just put it, okay, the is there any library it's already being there, okay, you just need to import it, that's it, okay. You just need to write it just like we did it, okay, the queue int and we have written, okay, and it's already gonna be importing also. Okay, you don't need to write it anything. Okay, and after that we can just write it q dot pop. We wanted to just see what is gonna happen from the front after the pop. As the stack and full stack, no, it's not same. Jagdish, this concept comes into the data structures algorithm, the stack. Okay, the full stack means like, okay, it comes with just a normal web development. Okay, it's not that stack. Okay, don't be in that dilemma. So front after pop, what is the action gonna happen? Q dot front. Okay, after that again copy it. We wanted to see the queue size, so you can just write it the size of the queue. Okay, queue size, q dot front, okay, or size, you can see it easily. Okay, and then you can just go with an indel. Okay, once you do that, now you wanted to see if anything is empty, so you can replace it with q dot empty. See out stack is empty or not. Okay, else like this. Okay, so let's just run. What would be the output, please? Okay, let me hear it from your end. What would be the output? Let me just hear from your end. Come on, let me know, please. Yeah, you can give it, Mukesh. You can definitely replace it. You can just have a look, okay, with it. What would be the output, please? Can you let me know? Come on, I'm just waiting for your response onto it. Come on. What would be the output of this program? Okay, one answer I've got it. 10, 30, 22. Okay, what about rest of you? That also I'll tell you. Okay, why we did not. But first of all, tell me what is this. Check it. The output for this is here 10, 30, 20 and 2 stack. It's not stack, it's in queue, so I'll write it queue over here. Queue is not empty. Check it. So let's just go with again, so you can see this. Correct. Perfect, Mukesh. Very good, Neha, Mohit, Priya, Gautami, Sai. What error it's there, Manikanta? There's no error, but only the stack was replaced. Okay. Very good, Dharya. Kirtana, very good. Aman Kumar. Syambu, also very nice. Right, so basically, yes, first of all, what happened is queue, we wanted to write it first in, first out. Okay, the front element view, we wanted to just take it care about it. Okay, now whatever the condition would be there, let me just tell you what is the particular output is there of explaining the output. First of all, why did we write it? Okay, is 10, 20, 30 is the queue we have pushed. Okay, then it will become 10, 20 and 30. Secondly, we will be having q dot front. It will show the front of the queue, that's 10 obviously, right? Then we have q dot back. Okay, it will show you the back view of it, correct? That's 30. Then we asked like, okay, remove the front element. That way it will remove the q from the front element. Q will become 20 and 30. Then we have asked about q dot front. So the front element we will get, okay, after removing the 10, it will be basically the 20 only, right? Okay, and how does it's gonna be there is the 20 out of it. Okay, then we have q dot size. Okay, the size which will be left behind, okay, is the 2 elements. That's basically 2 itself. And if the q is empty, no, obviously the q is not empty, we are still left with the 2 of the elements, correct? So that would be according to it. Okay, it will just try to get it, okay, symbols like that. Okay, yeah, definitely you can put it. Okay, the nq also. Okay, let me just tell you. If you wanted to see the nq and the dq, okay, what you need to do, okay, as one of the condition into the codes and all, the terminology will be same, okay, but only the condition is it will reflect on to what you need to write it. Okay, nq and the dq operations, correct? If you just need to see that, okay, operations from the front end side, okay, or the back end side, that depends upon these terminologies. Okay, view from the front, view from the back, okay, rear and the front, okay, of the elements, you can just write it easily, right? So this could be one of the main approaches, okay, you can just say. Clear? Now let's move to the linked list. Okay, it will take a few minutes. Okay, what is a linked list? A very important key points are being there. Okay, we know a simple link, or I would say the simple list which is being there is it comprised of the square brackets, okay, with the element placed into it, right? The square bracket with the elements inside it, correct? Now inside, okay, the values, whatever we need to remember, or whatever we have to say, okay, inside the particular conditions, the linked list plays a major role. Okay, and what is a linked list? It's data structures which compose of the sequence of data where each node can contain the data and the pointer. So pointer is just like a reference, and those who haven't attended the class of yesterday, it's a very gonna be a loss for you because we already did the pointers last particular session. Okay, and inside the linked list, okay, it's like just like in the contiguous, okay, the memory, the continuous memory would be there. Just like let me just tell you, I can take it a help from my documentation itself. Just like that, two of the boxes are being there, one complete box is being dependent upon two individual boxes, data and the next. Data could be int, float, character, boolean, any data type would be there, but whereas the next is just a pointer which is making it the reference out of it, which is storing, which is like managing the collections of the data, which is having the fixed size also because it's a linked list. Okay, at the time of the declaration, the array requires a fixed size. Okay, the resizing of the arrays could be there, the resizing of the operations could be there, okay, among what you are just trying to write it. Okay, and the memory is allocated with that. Okay, just data is where you are just storing the simplest kind of the type of the data elements. Secondly, you have the pointers which is going to have the reference to the next particular way. Correct. Now after it we have singly, doubly and the circular linked list. Okay, all of them basically makes a sense like, okay, when you make a nodes, more and more nodes are being there, just like each nodes would be there. One doubt is there. Okay, does the linked list plays an important role in online games, like linking the players from the various members? What I would say 20% of it only. Okay, the 20% of that it prevails this particular logic, but 80% it is not like that. It is something another logics are being acquired while. Okay, 20% I can exactly say. Take it. An advantage of the linked list is like what, when you just try to string basically with an execution, with the position you already know, like, okay, you know it, okay, and you wanted to just execute with the certain approaches. okay, the certain kind of logics and everything. Okay, and after all, the condition will render. Okay, the condition will just still have that particular nodes. Okay, how to write it, but how do we need to write it? Okay, this is the common operations and the complexities are being there. But the point arrives, okay, how do we have to go with the linked list, right? We have a queues, okay, we have, I would say, the conditions, okay, we are just trying to write it, okay, now. But doesn't matter, like, okay, why the conditions we are writing it. Although the conditions will already be going to be having the basic operations like that, how do we write it? Okay, because in Java it's very easier. How do you write the linked list? Okay, it's quite good, okay, to be written for or to be sent, okay, with the more changes it has, correct? But entirely the single operations of it, it resembles like this, these chains, okay, it's being there. So these kinds of a chains are being there. If it's on doubly nodes, okay, there is two heads, okay, over there, node and the head. So there would be like this doubly, where it has been gone. Okay, I've written it over here, data next, but it would be data next data. Okay, so it is the double heads, okay, would be there and all. Now let's see about the example basically as how do we write an example. So although these PPTs and everything, it's your only, it's not mine. Alright, so once we will be ending the class, I'll still give you the drive link. Okay, you can easily get it. Okay, the link of it using the namespace std. There is one class, we can make it node. Okay, node is basically like what? This is the basically the node only, the entire nodes, okay, of it, in which we will be containing data. And the next over here we will make a one public class, okay, and inside the public class we will put int the data, that's an integer, the integer value of it. So this integer value would be giving you the data. After that we can just write it the node which is gonna be connected to the next. Okay, so these kind of data and the next is both of them has been connected, correct? After all, we know in the node, first of all we will give a value, that's an int having the data type int, and after that give it the assignment, that's a value. Another one is the next, which is gonna be storing the value, a null pointer. Do you remember what it was, the PTR? If you remember what was the PTR, the pointer is correct, we did it yesterday. Okay, so after that, okay, this is done, the PTRs and everything. You can make one list, okay, a linked list, the class of the linked list. Okay, open it, okay, and give it a private class also, so that you can render it over here. Private, okay, node asterisk of it, head. Okay, now correct, pointer, PTR is pointer. Okay, now after that, once everything execution is being done, you can just try to resemble the linked list out of it. So it's a quite lengthier program, but still it has a good value. Now after all, we have the node, okay, which would be there, node head, one is the private class, another one we can make it the public class. Inside it, this is the nesting classes, the linked list. Okay, open it as one of the function, head also with a null pointer. Already we have already defined it, okay, null pointers, correct? Move it down a bit. Okay, now give it a void existence. Okay, with the void existence, okay, the concepts would be like, okay, what you need to write it, insert at the end or the front of it. Try and take, I'll do it, but first of all let's concentrate, okay, onto it, correct? I don't have any problem, but I'll give you, but let me just finish the program out. Okay, the another value which is being there, the node itself has a new node. Okay, the node, which is the kind of a lodge, is there, a wooden lodge, correct? And if that wooden lodge, okay, is gonna be broken, okay, into the, I would say, different pieces, okay, it will have the equivalent amount of the changes, correct? It will make the equivalent amount of the changes, okay, after it. So similarly, new node, okay, we will be just making it, okay, and inside this new node we will be referring towards a value we wanted. Okay, this is how we write it, the value. Okay, now the condition comes if the pointer action is gonna be displaying, right? So I'll tell you how do we write, okay, the pointer actions. Okay, it will become a bit long program, so it doesn't matter. I'll check my documentation. And this, with the pointers, first of all insert at the end. Okay, this insert at the end node would be there. Then we will be having is void as in of deleting at the start, okay, with the pointer you have. Then you have to display it for what you are just already writing it. Okay, once all of these conditions are been written, okay, or the condition you wanted to have the with the null conditions, you just simply gonna have the output. Okay, try and take, basically we wanted to just execute the properties, correct, of it, and each kind of a properties will be just sorted for what you are just trying to write it. Okay, so if you are just trying to write it with the minimal aspects, okay, try to write it with the minimal aspects only. Okay, okay, let's just give it an input output also. I'll just see that, okay, we can go with the same, compile. Just a minute, what's it's happening? Okay, also one thing more you can just do, okay, over here is print the output, okay, with how you just need to require with it. Okay, so you can just write certain amount of the questions, okay, out of it, that what you require and how you require it. Okay, it will just simply start, okay, resembling with the private and the input classes. Okay, ultimately the more approaches you require it is what the condition you're just trying to write it, okay, with the linked list. Yeah, it's same for all the languages, but only the syntax would be changing. Okay, and when the syntaxes would be changing, okay, it is only the syntax would be changing, the logics is also quite like normal, like 30% or the 40% of that, okay, it's quite simple. After that it's not, structure is different. So I can give you this program so that, okay, you can just have a look. I'm not sure whether we can just get it or not. Yeah, you can't get it. Check it. Correct. Now let's just see the output, please. Attendance sheet, I'm providing it to you. Just give me 1 minute. Let's see the output, please. Let's compile it. And let's see the output. So you can see that linked list 10, 20, 30 null. How we got it 10, 20, 30, 30 and all. 10 is inserted over here, 20, 30 first of all. And then nothing we have at the next one. So we will be just writing it null. Okay. After that we wanted to just go with 20, 30. After we are just going with deletion with of one element. Okay, that's 10. Okay, so once we go with that element deletion, so make sure you just try to write it these elements properly, 20, 30 and null. If after 10, 20, 30, 40, 50 also I have, after that it's null only, there is no other value which is being there. Okay, and when the value is not there, you don't need to write it. Okay, so here is your attendance sheet. So kindly please fill it. Okay, do not ask me again and again, ma'am, this time or that time or whatever it is. Okay, you don't need to follow it up. Okay, for your attendance sheets and all. Okay, here's your attendance sheets, please. Okay, have a look, please. I hope everything is clear. I hope every single thing is clear, right? Tomorrow, the last day of this boot camps, okay, we will be having it. Okay, that's basically we will be doing the algorithms for sorting, searching, and the problem solving. So that tomorrow we have a wrap up. Okay, so we are just all done with it. Okay, and you are ready to perform for a certain amount of time and all. Okay, it doesn't matter for what you're just doing it, and it is quite good. Okay, quite good, I'll say. Clear? Okay. Chalo. Okay, then thank you everyone. Take care. Bye bye. Have a nice day. Thanks a lot. Okay, let's meet tomorrow for the last time. Okay, and I hope everything is gonna be sorted. So you can take my LinkedIn profile from the day one. It is there into the description. You can search for me, okay, as one of the techie Ansika. You will easily get it. Okay, and if you still need the link, okay, you can search for the day one of this particular bootcamp. It's already presented on to I would say the description box. Thank you guys. Thank you everyone. Okay, notes also. I'll just give it to you. Didn't you got it into your community? I hope you got it into your community. Suggested folder. So here is your drive file also. Okay, so you can have a look onto this drive file. You can fetch for your notes if you wanted any of it. Okay, you will easily get that notes. And I've put okay for the day 4 also right now. Okay, thank you guys. I've uploaded it. Thank you everyone.